Hey everyone, so in this video I want to talk about the beginnings of linear motion. In particular, I want to discuss how in physics we can measure how far someone has traveled and how there's a few different ways we can actually go about that. So first I want to actually give a little scenario. So let's say you're traveling in a car, you travel along one path, you wind back, you go forward to another location, you come back, and then you end up in your final location over here. You call someone up and they decide that they want to meet you uh, where you are. If you want to get them to, if you want to try and tell them how far you've traveled as a way of getting them to find you, well, you could tell them how far you've traveled altogether and say, oh, I traveled a total distance of 44 miles. And while that number isn't completely useless, it doesn't really help the person in this scenario because that 44 miles is including a lot of loops and turns. So for all that person knows, that 44 miles could either be a straight shot in one direction, or you could have been looping around in circles and then landing in the house next door. So instead of telling him this distance, instead we can talk about how far we are from where they are. So if we did that, or say, I landed 10 miles away from the initial location, that would be a little bit more useful. In addition to this number, though, again, going back to the idea of needing the person to figure out where we are, that 10 miles could be in any direction. So we normally would want to include an additional direction to the east or something to let the person know exactly which way to go. So these two measurements are both measurements of how far you've traveled, but they are related to two different process and methods. One talking about the entire path you traveled, while the other one's looking at only where you end up. So where did you start and where did you end? Because of that, because these two paths, these two lengths of travel are different in the type of information that they're conveying, we give them different names. The first one is distance, as you can see, and the other one's displacement. So the official definitions we give distance and displacement is that distance is that total length of the path traveled, and displacement is the straight line distance between start and end. And this one normally does also include a direction as well. So distance, you wouldn't normally include a direction, but displacement you would. So other ways of saying this is that you're talking about, how far away that endpoint is from the starting point. And in both of these cases, because these are both representing how far something has traveled, they're both going to be measured in meters. And in AP Physics, the distance and displacement typically are represented by the symbol x. Usually, x is actually representing the position of something. And then when you go to find displacement, because displacement is the change in your position, how, between where you start and where you end, a lot of times displacement's actually given the symbol delta x. But pretty much the same thing. Though if you're in regions or in another class, you would most likely see distance and displacement given the symbol d. You'll probably see me go back and forth between them, or at least in this beginning part. All right, so some examples of the difference between distance and displacement. So again, because distance gives you the full length, it doesn't really discriminate between direction. And it can't really tell the difference between whether or not you're going in a straight line or you're going all around in circles. So a good example of this is if you go onto a track, typical tracks are each lap is about a quarter of a mile. If you go on a track and you run 8 full laps, then you ran a total distance of 2 miles. Other examples, if you're wearing a Fitbit or an Apple Watch or some sort of tracker, GPS thing, typically the distance is being recorded by the number of steps. Your phone can also record how many steps you've taken and use that to figure out the distance. Odometers in cars give your distance. They care about only the length you travel, nothing else. If you pop your car in reverse, it doesn't decrease the odometer. Displacement, on the other hand, cares about where you start and where you end. So in this case, if you using the same scenario where we go on the track and you take 8 full loops, here our displacement actually will end up being 0, as long as we're ending at the same starting point. So with distance, the number always goes up. There's no way to decrease it. It's constantly going up. But with displacement, we actually can decrease the number. We can increase it by going in one direction, and then going in the reverse direction basically brings it down. These two diagrams kind of represent the same idea, that with distance, it's the entire path we travel in all these cases. But the displacement is only from start to finish, a straight line. An old time phrase is something like how the crow flies, basically saying that idea that if we just imagine a scenario where we could go straight to our final location, how far away is that? It kind of is the same idea that there is a slight difference between the distance you travel and how far you actually land. One thing to also note about this is that distance is, for the most part, let me find my cursor, distance is typically going to either be greater than or equal to the displacement. You'll never see a case where distance is less than displacement, because what that essentially means is you just teleported. You covered a shorter distance than where you end up. But there are a few cases where your distance will be equal to your displacement, moving in a straight line. The only time you really need to actually note the difference between distance and displacement is the moment you see in your question that you make a turn. If you have an object moving in a straight line, distance and displacement are the same thing, except with an added direction. But they're very interchangeable. But once that path has a different direction, once you go from moving to the right to moving north or up or to the left, then you have to really read the question carefully, pay attention to whether we're supposed to be looking at distance, displacement, and what equations will go with that. All right, so here's a practice question. Pause the video, work itself, and we'll go over in a second. All right, so in here, you have to pay attention to the wording in here. The whole court is 30 meters, but it says that the person goes from one end of the court there and back, making a full loop. So it's 30 there, 30 back in 60 meters. So one full loop is 60 meters. He does this 3 times. So 60 times 3 gets us 180 meters. So if you got 90 meters, most likely you forgot to take into account that the question says there and back. The other thing to note is that the time was irrelevant and just a red herring. And also, like I said, you wanted to pay attention to whether we're talking about distance or displacement, because if this was instead asking about displacement, then because he's doing a there and back type process, the displacement will end up being 0. So again, depending on what the question says, it will change how we go about it. Here's the next question. Pause the video, work itself, and we'll go over in a second. All right, so in the scenario, we have a player who runs 27.4 meters, runs an additional 3 meters, and then returns back another 3 meters. So he's starting at this location and he's ending at this location. Now they're saying, compared to the total distance traveled, what is the total displacement? So what we're going to do is, let's just figure out what distance and displacement both are, since they mentioned both of those in the question. Well, as we mentioned before, distance is that total length traveled, not taking into account direction. So we take the 27.4 and add the 2 3s there and back to get a total distance of 33.4 meters. Displacement, because it does take into account, start to end, and it does take into account direction, if we tried to do the same thing here, we'd have to make sure that the 3 meters get canceled out, because moving 3 meters forward but then moving 3 meters back means that you didn't really do anything there. So the only part of the displacement is just that initial 27.4 meters. Now, going back to what the question's asking, it wants us to compare these two numbers. So compared to this, how can we describe this? Well, this number is smaller, so it's smaller than the 33.4. And to be a little bit more precise, it's exactly 6 meters smaller. So we would say is that the displacement is 6 meters less than the distance. And again, this fits with our initial statement that the distance should always be the bigger number, or at least greater than or equal to the displacement. And that's pretty much it as far as distance displacement goes. There's a few other things that I want to talk about in the next video that will kind of help with some of the more complex setups, but that's all you really need to know is just that main definition about the difference between them and how, or in particular, why we have two different terms for essentially the same thing. All right, if you have any questions, feel free to let me know. Otherwise, good luck and have a great day.